Welcome back to the second segment of our Ahead Fall Summit. I hope you enjoyed Michelle's talk earlier, as well as our discussion with Dan, Mike, and Ram from our Chief Data Officer panel. Our next two sessions feature two Ahead experts, Matt Sweetnam and Eric Mader. Matt's going to talk about defining a modern data architecture, how to build an environment for discovery and exploration within a framework of modern security and governance. Eric on applying DevOps and agile thinking to data analytics. One of the core tenets of modern technology, including data practices, is cross-functionality, which unfortunately often flies in the face of today's data governance practices. So Eric's going to talk about how to do both. Again, I want to thank our sponsors, DataRobot, VMware, Cohesity, Confluent, Dataiku, HashiCorp, and Starburst. Please be sure to visit their virtual booths, and please be sure to fill out the feedback survey that you'll find on our portal here. We do appreciate you being here today so much. So with all that said, let me turn it over to Matt Sweetnam of Ahead. Enjoy the sessions. Matt, take it away.
Hey, thanks, Tom. So today we're going to talk about the modern data environment, some of the challenges that we've seen, and present some of the solutions that may help you in your journey. So our agenda today, essentially in this talk, we'll be touching on the current situation that many organizations are finding themselves in. What has led up to the challenges that we've been facing, touching on some of the old and ingrained processes and perspectives that have contributed to our current situation, what some of those difficulties actually are, and once we have some of these challenges identified, we'll highlight those attributes that we feel a modern data environment requires to be successful. After we've covered some of the challenges, we'll walk through an approach that we found to address some of these problems. We'll start with the conceptual architecture, define what should be in the environment, how it should work, and how work is governed using this approach, and also our view on how the team should be made up to take advantage of this new environment. We'll wrap up the end of this talk with a review of the benefits the approach offers, and then we'll move into a question and answer period. So, everything all the time. I think that's the motto of the modern data environment. In the modern data environment, we're finding ourselves with a new set of users: data scientists, data engineers, advanced BI developers, and plain old business folks. They have a very different way of working than we're used to. They want all the data available within the organization, and they want to bring it together now. They want external data when it's required or just interesting, and after they've done working with it, it often just goes fallow. Essentially it ends up laying around inevitably with no one understanding what it's there for or why it's there, and essentially cluttering up your environment over a period of time. To add insult to injury, the data that they want is often complex. Sometimes it's structured, sometimes it's unstructured, and they look for their IT staff to be able to provide them both the data and the understanding of what's actually in the data once they get it. So some of the things that they want to do in that environment require massive amounts of compute, albeit potentially for shorter periods of time, or even massive amounts of data. And all of this is happening when the business of today is hyper-focused on data security. So how are organizations attempting to satisfy all this demand from all these new user communities? Well, there are two models that many organizations are trying to use to manage their analytics environments, and both are based on previous development paradigms, and both are usually wrong. The first has analysts developing on their local personal machines, And then, generally speaking, there's some kind of hodgepodge integration on a common set of servers, and then they try to move that into a production-like environment. There are clearly many limitations with this approach. It's limited in capabilities, both for data and for compute. And when it comes time to productionalize these solutions, you face the difficulties with getting the solution working in a very different environment from that which it was built. The second way that folks are using apes the software development lifecycle with a dev, test, and production environment. So it attempts to have all of the users working in one large, production-like development environment, after which models and code can then be promoted through the higher environments, sidestepping the problem of the previous approach, which is code and models being built in different environments. However, there are problems with this approach. Essentially, the problems they run into in this sort of environment is their lack of support, essentially, for the kind of work that data science entails. So that is, unlike normal software development, data science is very experimental in nature, with only a small percentage of the work actually amounting in a valuable outcome. So what that amounts to is pretty soon you end up with a lot of orphan data and analytics, or code. A recent study from Dataiku identified that up to 75% of data in today's environments is completely unused. All of this leads to what we have all come to know as the data swamp, as opposed to a data lake. A messy and difficult to manage environment that is almost impossible to clean up and also almost impossible to govern. To make matters worse, we're attempting to impose the same security and governance approach to analytics, which often seems to end up with IT being seen as the bad guy or the impediment to progress. So I think what we find is that both of these approaches have fundamental flaws with attempting to treat advanced analytics or data science in the same manner in which you would software development. So, the new ways of working require that we support more exploratory work. Essentially, if our users are going to be trying new things all the time, we can't spend tons of time standing up resources, preparing data, and working through access and security constraints. Rather, we need to be able to support a fail-fast approach, let users get to the data in a secure fashion, and quickly determine if this line of exploration is worthwhile. That lets the users get to the data, explore, and if the benefits aren't there, to cut our losses in both time and resources. So if we're going to support fail fast, it sort of implies that we're able to attach or insert governance to it. Otherwise, you can't actually tell when to fail out a particular effort. We've all probably seen the wide variety of demand in this environment. One week we'll have 10 different cases being developed demanding multiple compute clusters or vast amounts of storage, and a month later there'll be 2 efforts underway. So how we support the variability in resource demand without just provisioning for peak demand, both in storage and compute, and constantly installing and upgrading environment is going to be key. Similarly, all this data requires real expertise to understand. Enterprise systems have thousands of tables or entities, and when your data science team wants you to just give them, quote unquote, all the data, you can be sure they'll also be needing someone that understands the data and the structures and the relationships so that they can actually get to what they're looking for. And finally, if we're going to support a lot of exploratory work, how can we do that without spending a lot of time on security and access control, all the while assuring the information security team that we are actually operating in a secure fashion? The problem we listed in the prior slides can be addressed because we have a number of technology enablers to help us do just that. We talked about the variability in demand, and I think it's probably no surprise that we like to address that particular need with cloud services. We use infrastructure as code to enable us to allocate those resources in a predetermined way. To enable our solution, we found that breaking work into distinct cases allows us to manage them effectively. Using the aforementioned IAC components, we deploy pre-built and pre-authorized resources per case. And by pre-authorized, I mean pre-vetted by the information security team. Since we'll continue to redeploy the same resources over and over again via IAC, the security team can vet the resources once and never again. Building predefined analytics resources using IAC allows us not only to secure and allocate resources on demand, providing necessary elasticity, but importantly to deallocate and throw away environments once they've been completed. This helps us in avoiding the data swamp problem we discussed a few slides ago. Once a case has been promoted to production, the entire development area can be discarded, knowing that we can rebuild the environment along with the code or models on demand. So what kind of resources are we deploying, and what does it all look like? So there's a central data hub containing all the common data, cleansed and readily available. The hub also serves as a storage location for metadata about the datasets and any library or tools. Next, there are case templates. These can come, and should come, in a variety of flavors. These will be hydrated when needed for a specific case or work stream. As such, there will be several that will be necessary. We have in the past built environment catalogs that have case templates arranged around data access levels, as shown here in this example, and also around problem types like machine learning versus BI, or around technology stacks, or maybe even t-shirt sizes. So in this environment, or this example I should say, the environments are organized by access level. So it starts at public data, and it goes down to secret data and two others in between. What that means is this public environment would be deployed and actually provide users with access to only public data in the data hub, and have the availability to pull in their own libraries and possibly even untested code libraries from public sources. At the other end of the spectrum, there's a case template for secret data. You can see that at the bottom. That environment would provide authorized users with access to corporate secret data, and as such limit the user's ability to fetch or push data externally, as well as removing any ability to download or install external untested code libraries. One of the really interesting components of this architecture is that the code to build these individual environments is also source controlled, allowing the IT organizations to incrementally improve case environments, as well as tie concretely what the case environment looked like for a given source-controlled version of an analytic or model. So in reality, we can say that in production, we have a data science model version 2.1, and that it was built and tested in a confidential data case environment version 3.4. This gives you a ton of control and a ton of visibility into what is actually being built and how it's being supported. So what would it look like if we drew an actual implementation? So this is a physical diagram, and on the right side you can see a couple, looks like 5 case environments and a centralized data hub. The data hub at the center bottom has all the data these case environments need. It has direct access to internal enterprise data systems and data sources from which it pulls data, along with external data that is commonly used and can be shared amongst the case environments. At the end of an individual case, the governance process can determine that the case has useful or commonly useful data that can be reused by others in the organization that can then move that data into the data hub where it can be shared. The data hub also maintains metadata, documentation, and other common resources. Now the case environments are the things of interest, I think. So around the edges here you can see a case environment in a dotted square in the top left. These case environments are, in this case, self-contained virtual networks with all of the services that are required by the case template. So these things often include a development environment for data scientists, some kind of clustered compute engine like Spark and Spark cluster, and local data storage. And as I mentioned previously, as this is a complete environment unto itself, all of the security tools and monitoring can be built in, and built in once. Regarding data access, so while these can be customized by need, there are usually two ways that we provide the individual environments access to data. The first is we often build scripts into the case template itself that will pull specific data from the hub into the environment, making the environment itself pretty self-contained. Now that works if you have relatively small data sets, but alternatively you can give the environments access to the data hub directly. And as I said, this is usually determined by how much data we're talking about in terms of the move. What we don't usually do is give those enterprise case environments access to enterprise data resources in the enterprise itself, so enterprise databases or warehouses in the enterprise. They're all basically taken through the data hub, which gives you a lot of control over what data is available to the cases, and it also reduces demand on enterprise resources, and it simplifies the development and deployment. So let's talk about governance for a second. So clearly we get elasticity and security and control from this approach, but what we're also getting is a real handy mechanism for inserting governance and control. So if we're hydrating or creating environments on demand for individual analytic cases, one per case, then we also have a way of governing that work. Essentially, before case environments are hydrated and put in place, the request for a case environment should include key case management metrics in the case definition. These things include a definition of the case, that is what they're trying to achieve, a definition of what success or done looks like, data access requirements, and some indication of the tools necessary to do the work. Once the governance process is begun, they will review the case and value proposition. They'll agree, and this is important, the governing metrics by which we will judge the work being done. Things like accuracy, margin, coverage, or any other key metric that we can use to assess the success, the ongoing success of the work being done in the case. They can allocate the budget, and this is another interesting piece in that since the environment is one per case, they can clearly understand what the costs are to run that particular analytic or model. They'll also agree timelines, when they expect to see results, allocate appropriate team and personnel, and then agree the case environment template to use. So in the previous example, we had the case templates defined by security access levels. So in this case, the governance committee would determine which of those would make sense for the case involved. Once the case has passed the case initiation, the environment gets deployed and work begins. So obviously we always, well maybe not obviously, but we always suggest an agile analytics approach that allows us at the end of each sprint or some other timely period to evaluate the case team progress using those very metrics that we provided in the initial case request, which determines if the effort should be continued or terminated. At the end of the effort, the governance team can decide on next steps, which can include moving the model or code into production, integrating new technology from the effort and the case environment into the general case environment templates, or integrating data into the data hub. So hopefully you can see how the idea of compartmentalizing the work into cases, providing the cases individual work areas to do the work, and following a simple governance process like this can offer you a fail-fast environment with a clean separation from other cases and providing transparency on costs and helps avoid the dreaded data swamp. So what do these teams look like to make all of this stuff work? Well, we like these teams to be long running, with the team owning the discovery and development as well as the ongoing operations of the analytic. This proves useful in getting the whole team deeply knowledgeable about the solution space that we're working in, but also the ins and outs of the analytic that's being developed. Organizing the team looks kind of like this. You'll notice they have a very cross-functional flavor to them. At the top of the team is some kind of product owner, and this person is responsible for owning the business case being pursued and understanding the benefits in the business case. Within the team, too, is someone who understands the data domain. So the data we're pulling from, in particular from enterprise systems, is usually fairly complex. Having someone that understands the relationship between the entities and how the whole fits together is a critical part of the overall team. Also clearly included in the team are the analytics experts. So this would be your data scientists, your data engineers who are moving and shaping the data, and then the other people that are necessary to build out the analytic model or code. And then finally, there's often visualization folks. That is the BI developers that are needed to put these outcomes in some kind of easily digestible format for consumption. So clearly there's other needs as this team moves forward. There's often need for technical expertise, some part-time help in configuring or troubleshooting technical problems in the environment. This is usually done outside the team as part of the overall environment management process. So hopefully you can see some of the benefits that come from taking this particular approach to your modern data environment. So some of those are case compartmentalization, the isolation of individual cases and everything that implies. Clear governance process that is governed by monitoring metrics that are defined at the beginning of an effort. Fail-fast support, so being able to monitor and then cancel projects that aren't panning out. Resource reclamation, scaling up but also scaling down, destroying entire case environments, removing data, compute resources, all in one fell swoop, without fear of destroying data that might be used by other cases or teams. There's elastic resource consumption. When there's 10 cases underway or 2, you're only using and paying for resources that you need at that moment. And then, interestingly, the pre-authorized security. Security is cleaner when the security team can review the entirety of the environment prior to any work being done. It's also faster when I don't have to have them do it every single time we approach a new analytic problem. So thank you for listening to me talk about this environment. It's something I have a lot of passion about. And now we'll move on to question and answer time.